Welcome to JavaScript, Chapter 7, Using Object-Oriented JavaScript. When you complete this chapter, you'll be able to explain basic concepts related to object-oriented programming, use the date, number, and math objects, and define your own custom JavaScript objects. Object-oriented programming allows you to reuse code without having to rewrite it for a specific situation. Object-oriented programming refers to the creation of reusable software objects that can be easily incorporated into multiple programs. The term object specifically refers to programming code and data that can be treated as an individual unit. Objects are also called components. The term data refers to information contained within variables or other types of storage structures. In Chapter 1, you learned that the procedures associated with an object are called methods, and that the variables associated with an object are called properties or attributes. Objects can range from simple controls such as buttons to entire programs such as database applications. In fact, some programs consist entirely of other objects. You'll often encounter objects that have been designed to perform a specific task. For example, in a retail sales program, you could refer to all the code that calculates the sales total as a single object. You could then reuse that object over and over again in the same program just by typing the object name. Popular object-oriented languages include C++, Java, and Visual Basic. Figure 7.1 illustrates that you can form a program by connecting objects you create on your own with existing objects that have already been created by other programmers. Objects are encapsulated, which means that all the code and required data are contained within the object itself. In most cases, an encapsulated object consists of a single computer file that contains all code and required data. Encapsulation places code inside what programmers like to call a black box. When an object is encapsulated, other parts of the program cannot read or modify the code itself. All internal workings are hidden. When you include encapsulated objects in your programs, users can see only the methods and properties of the object that you allow them to see. Essentially, the principle of information hiding states that any methods and properties that other programmers do not need to access or know about should be hidden. By removing the ability to see inside the black box, encapsulation reduces the complexity of the code, allowing programmers who use the code to concentrate on the task of integrating the code into their programs. Encapsulation also prevents other programmers from accidentally introducing a bug into a program, or from possibly even stealing the code and claiming it as their own. In JavaScript, the document object is encapsulated, making it a black box. You can access the document object using its interface, which consists of its properties and its methods. For instance, you can incorporate the getElementById method of the document object in your programs. However, doing so does not require you to work with the code that makes up the document object itself. Figure 7.3 illustrates the concept of a black box using JavaScript in the document object. Another example of an object and its interface is a word processing application such as Microsoft Word or Google Docs. Each application is itself an object made up of numerous other objects. The program window or user interface is one object. The items you see in the interface, such as the buttons along the top, are used to execute methods. For example, the bold button executes a bold method. Later in this chapter, you'll learn how to create or instantiate an object from built-in JavaScript classes and from custom classes that you write yourself. However, as a conceptual example, consider an object named bank account that contains methods and properties that you might use to record transactions associated with a checking or savings account. The bank account object is created from a bank account class. To use the bank account class, you create an instance of the class. A particular instance of an object inherits its methods and properties from a class. That is, it takes on the characteristics of the class on which it was based. The bank account object, for instance, would inherit all of the methods and properties of the bank account class. In object-oriented programming, the code, methods, and attributes and other information that make up an object are organized into classes. To give another example, when you create a new word processing document, which is a type of object, it usually inherits the properties of a template on which it's based. Because objects in the browser object model are actually part of the web browser, you don't need to instantiate them in order to use them in your programs. For example, you don't need to instantiate a document object from the document class in your JavaScript programs because the web browser automatically instantiates one for you. However, you do need to instantiate some objects from the built-in JavaScript classes that you'll study next. The JavaScript language includes the 13 built-in classes listed in Table 7.1. Each object contains various methods and properties for performing a particular type of task. The arguments object retrieves and manipulates arguments within a function. The array class creates new array objects. The Boolean class creates new Boolean objects, and the date class retrieves and manipulates dates and times. The error class returns runtime error information, and the function class creates new function objects. The global class stores global variables and contains various built-in JavaScript functions, and the JSON class manipulates objects formatted in JavaScript object notation, otherwise known as JSON. The math class contains methods and properties for performing mathematical calculations, and the number class contains methods and properties for manipulating numbers. The object class represents the base class for all built-in JavaScript classes and contains several of the built-in JavaScript functions. The regEx class contains methods and properties for finding and replacing characters in text and strings. It's short for regular expression. And the string class contains methods and properties for manipulating text strings. Instantiating an object. You can use some of the built-in JavaScript objects directly in your code, while other objects require you to instantiate a new object. The math object is one that you can use directly in your programs without instantiating a new object. The example on the screen shows how to use the math object's pie property and power method in the statement. Unlike the math object, other objects require you to instantiate a new object before you can use them. There are two different ways to create a new object, using the object's constructor or using a literal. For instance, as you learned in Chapter 3, arrays are represented in JavaScript by the array object. The following statement shows an example of how to instantiate an empty array named department heads using an array literal. Var department heads equals, and then an opening and closing pair of square brackets. Likewise, you can create an empty generic object using an object literal. The following code creates an object with the name accounts payable using an object literal. Var accounts payable equals, and then an opening and closing pair of curly braces. Notice that unlike an array literal, which uses square brackets, an object literal uses curly braces around its values. Instantiating objects with literals is generally the preferred method among programmers because it's easier than using a constructor. However, one built-in object, date, does not support the literal format. Therefore, to create a date object, you must use the date constructor. The last statement on the screen uses the date constructor to create a date object. Var today equals new date, with an opening and closing pair of empty parentheses. If you've worked with other object-oriented programming languages, like Java, then you may be familiar with the term garbage collection, which refers to cleaning up or reclaiming memory that's reserved by a program. When you declare a variable or instantiate a new object, you're actually reserving computer memory for the variable or object. With some programming languages, you must write code that deletes a variable or object after you're through with it, in order to free the memory up for use by other parts of the program, or other programs running on your computer. With JavaScript, you don't need to worry about reclaiming memory that's reserved for your variables or objects. JavaScript knows when your program no longer meets a variable or object and automatically cleans up the memory for you. Three of the most commonly used JavaScript classes are the date, number, and math class. The date class contains methods and properties for manipulating the date and time. It allows you to use the current date and time or a specific date or time element, such as the current month, in your JavaScript programs. You create a date object with one of the constructors listed in Table 7.2. The empty constructor creates a date object that contains the current date and time provided by the device. The empty constructor uses an opening and closing pair of empty curly braces. The next date constructor accepts an argument, milliseconds. This constructor creates a date object based on the number of milliseconds that have elapsed since midnight, January 1st, 1970. The third constructor accepts an argument, date string. This constructor creates a date object based on a string containing a date value. The last date constructor accepts several arguments, a year, month, day, hours, minutes, seconds, and milliseconds arguments. However, only the year and month arguments are required for this constructor. This constructor creates a date object with the year and month arguments, and also the day, hours, minutes, seconds, and milliseconds arguments if provided. The statement at the top of the screen in the example demonstrates how to create a date object that contains the current date and time provided by the device running the program. Var today equals new date. The day of the month and the year in the date object are stored using numbers that match the actual date and year. However, the days of the week and months of the year are stored in the date object using numeric representation, starting with 0, similar to an array. The numbers 0 through 6 represent the days Sunday through Saturday, and the numbers 0 through 11 represent the months January through December. The following statement demonstrates how to specify a specific date with a date constructor function. In this example, the date assigned to the Independence Day variable is July 4th, 1776. Var Independence Day equals new date, 1776 for the year argument, 6 for the months argument, and 4 for the day argument. After you create a new date object, you can then manipulate the date and time in the variable using the methods of the date class. Note that the date and time in a date object are not updated over time with the clock. Instead, the date object contains the static, unchanging date and time as of the moment the JavaScript code instantiates the object. Table 7.3 on this slide and the next lists commonly used methods and properties of the date object. The getDate method returns the date of a date object, and the getDay method returns the day of a date object. The getFullYear method returns the year of a date object in 4-digit format, and the getHours method returns the hour of a date object. The getMilliseconds method returns the milliseconds of a date object. The getMinutes method returns the minutes of a date object. The getMonth method returns the month. The getSeconds method returns the seconds. The getTime method returns the time. And the Now method of the date object returns the current time as the number of milliseconds that have elapsed since midnight, January 1st, 1970. The date class also contains the setDate method, which sets the date 1 through 31 of the date object, and the setFullYear object, which sets the 4-digit year of a date object. The setHours method sets the hours of a date object, and the setMilliseconds method sets the milliseconds. The setMinutes method sets the minutes 0 through 59 of the date object, and the setMonth method sets the months 0 through 11 of the date object. The setSeconds method sets the seconds 0 through 59 of the date object, and the setTime method sets the time as the number of milliseconds that have elapsed since midnight, January 1st, 1970. The toLocaleString method of the date object converts a date object to a string set to the current time zone, and the toString method of the date object converts a date object to a string. The valueOf method converts a date object to a millisecond format. Each portion of a date object, such as the day, month, year, and so on, can be retrieved and modified using the date object methods. For example, if you create a new date object using the statement var currDate equals new date, you can retrieve just the date portion stored in the currDate object by using the statement currDate.getDate. If you want to display the full text for days and months, for example, Wednesday or January, then you can use a conditional statement to check the value returned by the getDay or getMonth method. For example, the following code uses an if-else construct to store the full name of the day of the week returned by the getDay method. Let's take a look. Line 1 declares and instantiates a date object called today. Line 2 calls the getDay method on the today object and assigns the value to a variable declared as currDate. Line 3 declares the third variable, weekday. And in line 4, an if-else statement begins in which the value of currDay is checked to see if it equals 1, 2, 3, 4, 5, or 6. If currDay is 0, we know the day is Sunday. So we assign the text Sunday to the variable weekday. If currDay is 1, we know the day is Monday, so we assign the text Monday to the variable weekday. And so on for the 7 possible days of the week. The following code includes an array named months with 12 elements that are assigned to the full text names of the months of the year. Var today equals new date, in which a date object named today is declared and instantiated. And var months, in which an array object containing the dates of the names of the months is created. And var curmonth, in which a variable named current month is created and accepts or returns whatever's in the months array at the month of the today object. In other words, returns the current month. The number class contains methods for manipulating numbers and properties that contain static values representing some of the numeric limitations in the JavaScript language, such as the largest positive number that can be used in JavaScript. As with the math object, you don't need to create a number object to access the number class methods or properties. Instead, you can simply append the name of any number class method or property to the name of an existing variable that contains a numeric value. Table 7.4 shows the class methods of the number class. The toExponential method converts a number to a string in exponential notation using the number of decimal places specified by the argument decimals. The toFixed method converts a number to a string using the number of decimal places specified by decimals. The toLocalString method converts a number to a string that's formatted with local numeric formatting style, for example, periods instead of commas for the thousandths place in Europe. And the toPrecision method converts a number to a string with the number of decimal places specified by decimals, in either exponential notation or in fixed notation. The toString method converts a number to a string using the number system specified by base, and the valueOf method returns the numeric value of a number object. The primary reason for using any of the two methods listed in the preceding table is to convert a number to a string value with a specific number of decimal places that will be displayed to a user. If you don't need to display a number for a user, there's no need to use any of these methods. The most useful number class method is the toFixed method, which you can use to display a numeric value with a specified number of decimal places. For example, you may have a number in your program that represents a dollar value. However, depending on the results of the calculation or the value entered by the user, the number may contain more than the two decimal places that are acceptable in a currency value. Table 7.5 shows properties of the number class. The max value property refers to the largest positive number that can be used in JavaScript, and the min value property, the smallest positive number that can be used in JavaScript. The NaN property, which stands for not a number, represents the value, any value that's not a number. And negative infinity represents the value of negative infinity, or positive infinity represents the value of positive infinity. Note that there's little reason for us to use those properties. However, we listed them for the sake of completeness. Performing math functions with the math class. The math class contains methods and properties for performing mathematical calculations in your programs. Unlike the array, date, and number classes, the math class does not contain a constructor. This means that you cannot instantiate a math object using a statement, such as var mathCalc equals new math. Instead, you use the math object and one of its methods or properties directly in your code. For example, the square root method returns the square root of a number. The code var cur number equals 144 and var square root equals math.square root, passing in the argument current number, returns 12, the square root of 144. Let's take a look at the methods of the math class in table 7.6. ABS returns the absolute value of x, a cosine x returns the arc cosine of x, and a sine x the arc sine of x. A tan returns the arc tangent of x, and a tan 2 returns the angle from the x-axis of the point represented by x, y. The ceil method returns the value of x rounded to the next highest integer, and the cos method, cosine, returns the cosine of x. The exp method returns the exponent of x, and the floor method returns the value of x rounded to the next lowest integer. The log method returns the natural logarithm of x, and the max method returns the larger of its arguments, x or y. The min method returns the smaller of its arguments, x or y, and the power method, x comma y, returns the value of x raised to the y power. The random method returns a random number, and the round method returns the value of x rounded to the nearest integer. The sine method returns the sine of x, and the square root method returns the square root of x, and the tangent method, the tangent of x. Table 7.7 shows the math class properties. E refers to Euler's constant, which is the base of the natural logarithm, about 2.72. ln10 refers to the natural logarithm of 10, about 2.3. ln2 refers to the natural logarithm of 2, which is approximately 0.693. Log 10e returns the base 10 logarithm of e, approximately 0.434. Log 2e returns the base 2 logarithm of e, approximately 1.44. Pi returns the ratio representing the circumference of a circle to its diameter, approximately 3.14. And square root 1 underscore 2 refers to the square root of 1/2, which is approximately 0.707. Square root 2 refers to the square root of 2, which is approximately 1.41. As an example of how to use the properties of the math object, the following code shows how to use the pi property to calculate the area of the circle based on its radius. As you probably remember from math class, the area of the circle is given by pi r squared. The code also uses the power method to calculate the radius raised to the second power, and the round method to round the value returned to the nearest whole number. The code is var radius equals 25, followed by var area equals math.pi, which accesses the math's pi property, times math.pow radius comma 2, which raises the radius to the second power, or in other words, squares it. So we end up with pi times the radius squared. The last line of code in this example creates a new variable called rounded area, which is given as the result of rounding the resulting area to the nearest integer. Defining custom JavaScript objects. JavaScript is not a true object-oriented programming language. You can base objects in your programs on built-in JavaScript classes such as the array and date objects. However, you can't create your own classes in JavaScript. For this reason, JavaScript is said to be an object-based programming language instead of an object-oriented programming language. Nevertheless, JavaScript does allow you to define your own custom objects. Unlike objects that are based on classes, custom objects in JavaScript are not encapsulated, which means that other programmers who use your custom object can see inside of the black box, even though custom JavaScript objects cannot be encapsulated. You might find them useful, especially if you need to replicate the same functionality of an unknown number of items in a script. For example, you may have a website that allows customers to place online orders for items you sell. For each order, you may want to create a new object that uses properties to store information such as a customer's name, order date, payment method, shipping date, and so on. The object may also contain methods that calculate sales tax and sales total. Although you could use the standard functions and variables to create the same functionality, the ability to treat each order as a self-contained object would make your job as a programmer a little easier. Declaring basic custom objects. Although JavaScript is not a true object-oriented programming language, you can create basic objects and properties by using the object. You can declare a custom object with the object constructor as follows. Var object name equals new object. However, it's easier to declare an object using object literal. You can create an empty object by assigning a pair of empty braces to a variable name as follows. Var object name equals and an empty opening and closing pair of curly braces. You can add a property to an object using dot syntax by specifying the object name followed by a dot in the property name, and then an equal sign in the value. For instance, you could use the example on the screen to create an empty object named inventory list. And then, that's not exactly right. To create an object named inventory list and assign the value using the following statement. Inventory list.inventory_date equals new date, passing the arguments 2017, 11, 31. So I misspoke. If inventory list is already created, then you can create its inventory date property using the code on the screen. But you would have to create an inventory list object first by using the code var inventory list equals, and then an opening and closing pair of empty curly braces. One reason that creating objects using literals is generally preferred is that you can declare an object and its properties all in a single statement with a literal. To declare a property within an object literal, you specify the property name within the braces followed by a colon and its value. You must separate multiple property value pairs with commas, as in the example on the screen. The example on the screen creates the performance tickets object with the code var performance tickets and adds the customer name, performance name, ticket quantity, and performance date properties in a single statement, everything that follows. Declaring subobjects. In addition to strings or numeric values, object properties also support other types of values. The value of a property can be another object, which is known as a subobject. For instance, the following code creates an object named order with a subobject named address. Var order equals order number, colon, and the order number, and then the subobject address, which itself contains a street, city, state, and zip property. The main object with the name order has two properties, order number and address, and the address property, a subobject, has four properties of its own, street, city, state, and zip. Referring to object properties as associative arrays. In a standard array, you can reference any value by its index number, which starts at 0 for the first element in the array and increments by 1 for each additional element. JavaScript allows you to refer to object properties using associative array syntax. An associative array is an array whose elements are referred to with alphanumeric key instead of an index number. For an object, the property name takes the place of an index number when using this syntax. For instance, if you stored the stoplight colors, red, yellow, and green, in an object, it might look as follows. Var stoplight colors equals, followed by stop red, caution yellow, and go green. You could reference the value for the caution property, which is yellow, using its property name, stoplight colors.caution. Using associative array syntax, we would instead put the property name in square brackets and enclosed in quotes, as on the screen, stoplight colors, followed by square brackets which contain in quotes caution. That would also return yellow. Creating methods. In addition to properties, objects in JavaScript can also have methods. A method of a custom object is simply a function that is assigned a name within the object. There are two ways to add a method to an object: by providing code for the method in the object, or by referencing an external function. You can specify a method name with an anonymous function as its value. An anonymous function is a function without a name declared in the function statement. Generally, this means that you can't use an anonymous function anywhere except where it occurs in your code. However, by assigning a method name to an anonymous function, you can then call the function using the method name. For instance, the example of code on the screen creates an order object with a method named generateInvoice. Another way to declare a method is to specify a method name and use the name of an existing function as its value, as in the example on the screen. The code begins by defining a function with the name processOrder. Then the object definition for order declares a method with the name generateInvoice, which has the function processOrder as its value. Notice that the syntax for declaring a method by reference to an existing function is the same as the syntax for declaring a property. The JavaScript processor correctly identifies methods because their values are functions. Also notice that the processOrder function is referenced without parentheses at the end. Using the code shown here to declare a method would not be valid because it includes parentheses. Enumerating custom object properties. Some custom objects can contain dozens of properties. For example, a script may create new custom object properties that store sales prices for each item a customer wants to purchase. Suppose that you want to discount the individual sales price by 10% of any items that cost more than $100. Because there's no way to determine in advance which items a consumer will purchase, we don't have a way of knowing which properties have been added to the object for each individual customer. To execute the same statement or command block for all properties within a custom object, you can use the for-in statement, which is a looping statement similar to the for statement. The syntax of the for-in statement is shown on the screen. For a variable in object, followed by one or more statements enclosed in curly braces. One of the benefits of the for-in statement is that it enumerates, or assigns an index to, each property in an object. This is similar to the way elements in an array are indexed. You can use an enumerated object property to access the values contained within object properties. A typical use of the for-in statement is to validate the properties within an object. For instance, the code on the screen here checks if any of the properties has an empty string as a value, and if so, it calls the generateErrorMessage method. The if statement refers to the prop variable as an index of the order object. In this code, the variable named prop holds the names of each property in the order object. Each iteration of the for-in statement checks the value of a property. The code passes the order object to the if statement, along with the prop variable enclosed in brackets. Order, square brackets, prop. You can use a statement to delete a property of a custom object. To do so, you use the delete operator with the syntax delete object.property. For example, the statement on the screen deletes the item in stock property of the order object. Delete order.iteminstock. Defining constructor functions. Another way to define your own custom objects is by using a constructor function, which is a function that's used as the basis for a custom object. Sometimes constructor functions are referred to as object definitions. As with traditional class-based objects, such as in Java, JavaScript objects inherit all the variables and statements of the constructor function on which they're based. Any JavaScript function can serve as a constructor. Let's take a look at this example constructor function. It includes 4 properties: customer number, order date, payment method, and shipping date. To add a property to a constructor function, you must add a statement to the function body that uses the this keyword with the following syntax: this.property_name equals value. In the case of a custom JavaScript object, the this keyword refers to the object that calls the constructor function. For example, the code on the screen includes 4 properties, and the statements preceding the constructor function use the this keyword to assign the values of the 4 arguments, number, order, payment, and ship, to the 4 properties: customer number, order date, payment method, and shipping date.